now the most important thing about data sufficiency questions is not actually solving them, but knowing if you can solve them. So looking at statement 1, are we going to be able to find out how many people attended this event? Well, I'm representing people with P and the phi with F. And the formula I get based on that first statement is F minus 75 cents times P plus 100 is equal to what we would have had without any change, which is just the phi times the number of people. Because this is how much money we'd earn if everyone was charged just the normal fee. Like if we had a $2 fee and there were 100 people, it would cost $200. So looking at this and knowing these are equivalent, we can FOIL out this situation here and we'll get this second step. And then we can subtract FP from both sides and move the 75 over to the right, and we get something that looks like this. But we don't know what F and what P are because we have two variables in one formula. This is insufficient. The second statement works out pretty much the same way, and we end up at this formula, which is also insufficient. But when I take the two formulas together, if you look at them, I could represent each formula in terms of 100F. So I could change this formula to be 100F equals 3/2 P minus 150. So I've just reorganized that, and you can work through that by adding 100F to both sides, then subtracting 150 from both sides. And I know that this equation, if I just add 3/4 P to both sides, gives me 100F equals 3/4 P plus 75. Well, if this equals 100F and this equals 100F, then these two sides must be equivalent, which means 3/4 P, this should be 3/4 P. 3/4 P plus 75 equals 3/2 P minus 150. And if I bring everything over to the appropriate sides, if this is a common base of 4, this would be 4/6, then I will get 225 equals 3/4 P. And if that is the case, then I have 4/3 of 225 is equal to P. And that means I have finished out and solved the equation. But I would never go this far because once I see that I have these two equations and they're different, two equations with two variables are almost always solvable. As long as these variables don't have exponents to deal with that could mess things up, and as long as these formulas aren't the exact same formula, just like one of them multiplied by 2 or something, for example, x plus y equals 10 and 2x plus 2y equals 20, these are actually the same formula. This one's just multiplied by 2, but this isn't the case here. These are actually distinct formulas. And for that reason, it's going to be solvable. And I was confident, even without doing the math, that the answer would be C.